Hello, welcome to episode 7 of Code a Game Like Minecraft in Unity. In this one we're going to optimize our chunk generation a little bit and create a debug screen. I'll try and get through this as quick as possible because I know it's not the tutorial you all wanted, but we do need to do debug screens, just an aside, but we do need to do the chunk optimization before we get on to breaking and creating blocks, because otherwise it will just be unbearable. So let's get straight into it. We want to get into our world script and we just need to make a slight, well, first off, I disabled the view distance checking in the last one because we didn't need it and there was some stuff that needed doing to it. So let's re-enable that now just by uncommenting these lines. And the other thing is, if you remember, we had player chunk card and player last chunk card, and the purpose of this was that we could set our player chunk card, which is where in chunk cards our player is right now. Chunk cards, if you don't remember, are the coordinates of the chunks in chunk space. So each chunk is currently 16 units wide. So 1 by 1 would actually in world space be 16 by 16, but the chunk card would be 1 by 1. That's what a chunk card is. So the player chunk card, we set that as to where the player is, and the last player chunk card, we set that every time the player, well, we don't set that at the minute, that's the problem, but we're supposed to set that every time the player moves to a different chunk card. So we start off, player last chunk card is wherever the player spawns in, and then the idea is we set the player chunk card every frame, and if at any point the player chunk card is different to the last chunk card, we run check view distance. However, we at no point set the player last chunk card to the current position after this first check, which means that the last player chunk card is always the spawn chunk, which is no good because it means that it's going to think that it's going to run check view distance every time the player is not on the spawn chunk, which is no good whatsoever. And the way we fix that is just in here, player last chunk card equals player chunk card, and that fixes that problem. So the reason we're optimizing our chunks, if I press play now, everything looks fine and all that, but you'll see if I start running off in a direction where there's no chunks, you see that horrible lag spike every time it generates new chunks in, and obviously that's no good. And if you imagine it's going to do that every time we try and break and punch a block, you'll understand why I'm doing this video before the next one. I mean, it's fine if you go back towards where we've already generated some chunks, but as soon as you hit a point where there is chunks that need creating from scratch, then you get this horrible lag spike. So the way we're going to do this, we're going to create a list, and the list we're going to call, it's going to be a list of chunk cards like our active chunks list here. And we're going to call it chunks to create. And then we need to go down to our create chunk. Where is it? There it is. And we're going to delete this entirely. And obviously remove it from there. We were adding to our active chunks when we called that create a new chunk thing. We don't need to do that. I mean, obviously we've deleted that now, but we don't need to do that separately for both of these. So we just put that one reference there, and then it works for both. And then what we're going to do in here is we're going to do chunks to create dot add, and then just create a new chunk card, X and Z. Oh, sorry. That should be chunk card, not chunk cards. Don't worry about this error for now. We'll fix that in a second. We'll head back over to our chunk. And basically what's happening right now when we create a new chunk is this constructor here means that whenever we create a new chunk, it is automatically doing all this, including populating the voxel map, creating the mesh data, creating the mesh. That is what's bogging the system down when we're creating a number of chunks. So what we want to be able to do is to create a chunk. We're going to need to create a chunk without doing all of this until we're ready. So we need to break this out into a separate function. And we're going to call it, it's going to be public because we need to get it from outside. We're going to call it init for initialization. And we're just going to paste all of that in there. And then we're going to take another value in here, and it's going to be a bool, and it'll just say generate on load. and that gives us the option to run the chunk creation as it was before. So if this is true, then we will run all this straight away and it will be just like it was before. But we can also set it to false and have it create the chunk but not populate the data that goes in that chunk. So if generate on load init. Right, the other thing we need to change is currently we are using our setActive by directly checking the chunk object, which isn't going to work anymore, because if we create the chunk but we don't initialize it, if this is false, then we haven't created a chunk object, a game object, so we can't check to see if it's active. So we're going to create a private bool. We'll call it underscore is active. And then what we're going to do is, instead of returning that, we're going to return underscore is active. But for setting it, first off, is active equals whatever value we're passed. And then we want to check if chunk object does not equal null. So if it doesn't equal null, that means that we have set the chunk object. It probably means that this, well, it means that this chunk is initialized. So if chunk object does not equal null, then set chunk object dot set active to value. So we've gone from using the chunk object's active state to determine the isActive value to using the isActive value to set the chunk's set active state. And then also up here, we want to set that to true. And now that we've done that, if we go back to world, we can change this. We're just going to go chunks xz equals new chunk, and then we're going to pass in a chunk code, which we'll just create from scratch. New chunk xz. The world value is this, obviously, and then because this one is the generate world, this one's run at start. We want all these chunks need to be generated before the player even enters the world. So this wants to be true. And then also we're going to want to add this to our active chunks list, because these chunks will be active. So the next thing we're going to do is create a coroutine. So the reason everything's getting bogged down when it creates new chunks is because our view distance covers however many chunks. I think it's currently set to 5. So if we walk off in a certain direction, we're creating a certain amount of chunks, probably around 5 with the current view distance, which means that each frame that the view distance is updated, at least 5 chunks are going to have to get created before the next frame can get underway, which is obviously, it's a lot of work to get done in whatever it is, 0.074 of a second, which is why it slows it down. It drops the frame rate right down because it has to complete that task before it can move on. What we're going to do is we're going to break up that into single chunks. So instead of doing all of the chunks at once, we're going to work our way through this chunks to create list and create them one at a time. And then we're going to do that with a coroutine. So if you're not familiar with coroutines, you use them by initializing an IE numerator. Basically, it's like a regular function, but you can yield at certain points. And what that means is it will get as far as the yield, and then it will yield to the rest of the code, and then for the next frame it will come back and it will carry on, and if it hits another yield it will yield again. And what that means is we can have loops. So you can have a for loop. If you had like these for loops in the generate world script, those for loops have to complete before the generate world function can finish. Whereas if this was an IE numerator and you put a yield function here, then it means that it would get that far, it would yield, and then it would come back and it would carry on looping. So each one of these, this would run once per frame, as opposed to run the whole thing to completion, and then you could move on. And the way we use these, so we're going to call it create chunks. And as you can see, it's already showing up an error because there's no yield in this coroutine. We're going to need a bool. And all this is, we don't want to try and start this coroutine if it's already running. So once we start it, the first thing we'll do is set is creating chunks to true. And then at the end, we can set it to false. And then what that means is that we're going to do a check, and if this is true, we don't run this we don't start this coroutine because it's already running. If it's false, it means we've finished if it was ever running, and we can start it again. And then in the middle, we're going to do while chunks to create dot count is greater than 0. So while there are any chunks in the chunks to create list, do this loop, and we're going to yield. We're going to yield spelled correctly. Yield return null in this loop. It's just going to keep looping through this loop while there are chunks to create in that list. And at the end of each loop, it will yield, letting the rest of the game continue with its code. So it doesn't matter if this list never gets empty. The rest of the game will carry on running fine around it. And then in here, we're going to get at our chunks map, and we're going to use the chunks to create at the 0 index. And if you don't know how lists work, if you remove an item from a list, this is why we're using 0, by the way. If you remove an item from a list, all the items below it shuffle up one space. So if you have 10 items and you remove number 5, then items 6 through 10 move up one space and become items 5 through 9. So we're always going to be working with item 0 in this particular function, because it means that we can remove 0 and all the items below it will shuffle up one space. And then we're going to initialize that one. So this is the part that uses all the processor power. This is the part that's creating all the voxels using the getVoxel algorithm, and then it is creating the mesh, which is quite intensive, and obviously applying the mesh and everything like that. So now we're initializing it, and then we're removing it from the chunks to create list, so we don't do it again next time, because once we've initialized it, we don't need to initialize it again. And then we're removing it, and then we're yielding. So it's working through this list, and it's doing one chunk per frame. So the most it will ever slow the system down is however long it takes to generate one chunk, not 10 chunks or 20 chunks, or however big your view distance is. Which in theory means that it should never, no matter what your view distance is, it should never bog your system down more than any other view distance, because it's only one chunk at a time. But what it could mean is if your view distance is that big, it could take that long to get through the whole list of chunks to update that your player has moved into the space where there's chunks that's not been updated yet, if you get what I mean. So it won't slow your frame rate down anymore having a bigger view distance, but it might get to the point where the player can see chunks popping into existence, or even get to a point where a chunk hasn't popped into existence yet, which could cause its own problems. But those are problems for later on. Now we've done that, we're just going to go back into chunk, and we're just going to make a few modifications to, that's world, we're just going to make a few modifications to our chunk code. So the first thing we're going to do, just for the sake of it while we're here, is we're going to add another constructor that will just allow us to create chunk codes without actually passing values in. So now we can create it with an X and a Z value, which straight away sets the X and Z value, or we can just create it with no values and it will give us a chunk code that is 0, 0. We don't need that, don't think we're going to need it, but just in case, it's there and it's not doing any harm. And then the chunk code that the constructor that we are going to use will just take in a vector 3. And what this is going to do is we're going to be able to pass in a vector 3, and this is going to do the necessary calculations to work out what the chunk code would be based on that vector 3. Int xcheck equals mathf dot floor to int pos dot x. Then we'll do the same for z, and then x equals xcheck divided by voxel data dot chunk width, and again same for z. So that just lets us create a chunk code directly from a vector 3, which is useful. And then if we go back up to our chunk, we're going to create a new function, if I find the right place to put it, near check voxel, because it's along the same lines. We'll put it here. This one's going to be public. The whole purpose of this function is for use by external scripts. So it's going to be a public byte get voxel from global vector3, and it's going to take in a vector3, and we're just going to rob these because we're going to need to do that again. We need to modify the x and z values based on the chunk. So x check minus equals mathf dot floor to int chunk object dot transform dot position dot x, and all this is doing is all this is doing is it's taking the x value, which currently represents the absolute x position of this voxel in world space, and it is removing the chunk's absolute position, which gets us the position of the voxel within this chunk. And then we need to do the same for z. We don't need to do the same for y because there is only one voxel vertically. And once we've got that, we return voxel map, x check, y check, z check. And if you notice, we're not doing any checks to make sure that the value that we're returning, the x check, y check, z check, we're not doing any checks to make sure they are actually within this chunk. And the reason for that is, if we're calling this function, we're calling it because we've already worked out that the voxel is in this chunk. We're not just going to go through all the voxels, all the chunks, past the position in and hope that we find the one that's got this voxel in. If we're calling this function, it means we've already worked out that the voxel is here. We just need to know what value the voxel is, which is why we're not doing an unnecessary check to make sure that the voxel is actually within this chunk. And another thing we're going to need is we are going to need a public bool is voxel map populated. It's going to equal false, and then at the end of populate voxel map we're going to set that to true. And all that means is we can check, because we're going to be checking these chunks at various stages. We could check it before it's been initialized, which is fairly easy to check, but we could also check it while it's initializing. We could be trying to check it while it's running this loop, in theory. So we need to know if it's got the voxel map already populated. Because everything is working from the raw data in these voxel maps, it doesn't matter if it's created the mesh or if it's created the mesh data or anything like that. All that matters to the rest of the game is whether that voxel map is populated. Because what we're going to do is, right now down here, we're calling the getVoxel command for any voxel that is outside of this chunk, but we don't always need to. Sometimes, like a lot of the time, we're going to be calling a voxel that's already been created, and we don't want to run that expensive voxel world generation algorithm every time we need a voxel. So what we're going to do is in world, we're going to create a new function, not a new function, sorry, we're going to redo this function. So the first thing we're going to do is get a chunk card, and we're going to use using our new ability to check to get a chunk card from a vector3, which is, we need to change this because that is going to be a vector3 now. It's silly having it as separate integers when we don't need to. So the first check we do is voxel in world, and if voxel is outside of the world, we're just going to return false. Nice and simple. Now the next chunk is where our new values come in. Our new is populated and whatnot. So if chunks, we're going to call this chunk.x, this chunk.z. So bearing in mind, if we get here, the chunk is definitely within the world. If it does not equal null, so if it doesn't equal null, it means that we've created it here. We've already, oh no, sorry, we haven't created it there yet. What we want to do here, sorry about this, chunks xz equals new chunk new chunk called xz, this, and then this one wants to be false. We don't want this one to initialize automatically, and we're going to need to put this one in curly brackets. So yeah, we've already created the chunk here, but we've not initialized it. We might not have initialized it. So if it does not equal null, that means we have a chunk there, and it's populated, then we can just go ahead and get the value from the actual voxel map in that chunk rather than generating a whole new one. Return get voxel from global, just pass in the pos value. Oh, sorry, this needs to be part of it. We're using this to get a block type. Dot is solid. And then finally, if we get down to here, we're just going to have to go to our expensive get voxel algorithm. And then if we go back into here, this one, instead of get voxel, world dot, completely forgotten the name of my own function, world dot check for voxel pos. Now the final thing we have to do, and I'm not going to make you watch this, but because we have changed our check for voxel to be a vector3 rather than 3 individual values, we now have to go into player and change all these. I'm not going to make you watch me modify all these, but basically we already have the structure in place. All we have to do is just put new vector3 and enclose all these values in brackets, and that will be enough. Because we're passing in the same values, we just want them as a vector3 now.
A few moments later.
So now that all that's done, like I say, just enclose all these references in vector3 brackets. We go to our world update, or wherever that is. There we go. And we just do a simple check. If chunks to create dot count is greater than 0, and we're not already creating chunks, then the way you start a coroutine is by literally typing start coroutine, and then you have to name it as a string, which I forgot what I called it. Create chunks. So we're not call it, if we're already running the coroutine, we're not going to call it again. Just noticed this here is this needs to be pos position, because this is a global value, not a in chunk value like this one. And I'm sorry about this, but for a reason that I haven't quite worked out yet, if voxel is in world isn't quite working properly. I did have this set up when I ran through this code beforehand to make sure everything worked. I did actually use a different line of code for this part, so it's my own fault for deciding to change it on the fly when I'm recording, but this line is currently not working properly. So here's what I did when I was setting up the code. Basically, if the chunk is in the world first, check that, and then do a separate check for the Y position. Make sure it's not under the world or above the world. And for some reason that is working when is voxel in world is not working. So I have to look into that. But for now, I don't want to bog this tutorial down with bug finding. This line of code works. I'll try and figure out what's wrong with that and either make a note or talk about it in the next video or something. But now we've got all that set up, and we should find that we can run around and new chunks will generate without completely lagging the game out. If I just switch this to an overhead view, you can see it in action a bit better. So as you can see, they're generating chunk by chunk now instead of all of the chunks at once. And it's still, I mean, it's not perfect, but I don't want to get into things like threading, at least not yet. Sebastian Lake's got a really good tutorial series on creating an endless terrain series, which is a different kind of thing, to a different kind of world to what I'm creating here with the voxels. But the concept for how he does his optimization on threading and optimizing the meshes and all that kind of thing could quite easily be transferred over to this. or parts of it can anyway. Anyway, we've got our world generation going. I just want to quickly get this debug menu that I was talking about underway. So the first thing we're going to do is we are going to create a folder called fonts. I found online a font called Minecraft CHMC. It's a Minecraftian font. It's a Minecraft font. It is, as far as I know, it says on the website that it's free for commercial and personal use. I will include a link to it in the video description, obviously. I'm just going to drag that in here. You don't need to do any import settings with it if you don't want to. Maybe you want to. That's entirely up to you. I'm not going to get too in-depth in how the UI system works in this one, because that's a whole other thing. And besides, and we're going to have to touch on that more when we get to doing the inventory anyway. So for now, I'm just going to cover what I need to cover to tell you to show you what we're doing here. So we're going to go into create an object, UI, and text. And as you can see, we've got this white square here represents the canvas, which is our current viewing area. If we change the size of that, it changes the canvas shape. It's currently on free aspect, but you could have it locked to widescreen or 4:3 or whatever. Minecraft, as far as I know, is quite free and easy about resolution, so you can have it any shape you want. So that's how we'll keep ours. The text object here, which we're going to call debug screen, is currently set to, it's got a central pivot point, and it's got a central anchor point, which means its positional values are the anchor point's position in relation to the pivot point position in relation to the anchor point. So what we're going to do is we're going to change our anchor point to be all four corners, basically, and stretch it out. So now its positional values are its distance from the 4 points. So left, we're just gonna give it a margin all the way around of 10. Call that debug text. We'll change the font because the font that comes with Unit is it's fine, but it's a bit bland. And obviously this is a Minecraft game. We're gonna want to make that bigger. 30 looks fine. And now we're gonna go into our world script, and we're gonna take in a reference for the actual game object that our debug screen is on. And then if we go into world, drag that in there, and then in our update, we're going to do a check for if input.get key down keycode.f3. I believe it is F3. That it's been a while since I played Minecraft, but I believe it is F3 that is the button you press to get the debug menu up, or the debug screen. So we'll use that. And then, because this is only concerned with turning the debug screen on and off, it doesn't matter to us what the current state is of the debug screen. All that matters is that we set it to the opposite. So the way we can do that is debug screen dot set active, and then we're going to set it to not debug screen dot active self. So now if we press play, we should be able to turn our debug screen on and off with our F3 key. Obviously, there needs to be more to it than that though. So if we go back to our scripts, and we're going to create a new one, which we're going to call imaginatively debug screen. And then we're going to put this on our debug screen object, and this is going to handle the actual information that goes on that debug screen. So the first thing we're going to want to do is we need to reference the UI system. We're going to be using a UI object, so we're going to need to reference the UI namespace. We need a reference to the world, and we need a reference to our text component. It's this text component that is why we need this Unity UI, because if I take that away, we have no component for text. Calling it text might get a bit confusing because it's the text component, this one here. So it's a text component. I've called it text, but we're going to need to modify the text value. So basically, we're going to be modifying the text component text, and then the text variable in that text is text. But I'm sure we can cope with it for now. We'll just rob a line out of the player just to save us typing it out. to get our world value, and then our text is a bit simpler because it's on the same object, so we can just grab it straight there. Now, as far as updating the actual text in that, we can do that in the update thread, because if you remember, we're turning this game object on and off from the world script. So if this object is running, if it's on, then that means that we want it to be updating. So we don't need to worry about calling a separate function when we want it, because if this script is activated, inherently that means that we want it updating. And the way we're going to do this is straight away, we're going to create a string and we're going to call it Debug Text. And we're going to set it to equal... well, the first line of text we're going to have, we'll just do this. Completely forgotten the name of my own YouTube series. The way I'm going to lay this out isn't the ideal way of doing this, but it's just, it makes it a little bit easier to follow along what's going on. So if you plus equal one string onto another string, it appends whatever you put onto the end of the last string. What I'm going to be appending onto this one is a new line, which is what \n means. And then, well, first off, let's see this in action. So text. It's a lot of text. If we press play now, we can see we've got our title that we've set in the code. Now we're going to deactivate this by default, because obviously you don't want the debug screen on when you by default you want to turn it on. And we're going to go back in here and we're going to get the next value we're going to have is frame rate. So we'll create a float for frame rate, and we'll create a float called timer, and I'll explain why you need that in a second. We're going to go down here, and if timer is greater than 1f, frame rate equals, we need to cast this as an int because we don't want all the float values after it, and we need 1f divided by time dot unscale delta time, and that gives us our essential frame rate. Now the reason for the timer is because the update runs once a frame, and the frame rate varies from frame to frame. So if we update the frame rate every single frame, it's going to be just a blur, because it can go from 55 to 60 to 68 or whatever, and just do that once a frame, bearing in mind that when you're getting 60 frames a second, that's something like 0.01 updates, 0.1 update every 0.01 second or something like that. So obviously that's not going to be very readable. So what we're doing here is we're only updating when the timer is greater than 1, and then we're going to increment the timer by the time.delta time, which means that 1 is equal to 1 second. So we're only going to be updating the frame rate every second, which makes it far more readable. So if it's greater than 1, set the frame rate, update the frame rate, set timer back to 0. Otherwise, if it's not greater than 1, timer plus equals time.delta time. And then we'll go into here, debug text plus equals, and we're just going to pass in frame. We're just going to pass in the frame rate value, and then plus FPS. So now we should have... Sorry, when I disabled that, I meant to disable the actual object, not the script. Now we should have a frame rate. There we go. It took a second to update, but we have a working frame rate. And you will see it drop when it brings in new chunks, even though the chunks aren't really holding the game up anymore. Yep, there we go. It dropped down to 24 there for a second. But it was only for a second, and it didn't hold the game up noticeably when we were playing it, so... For now, it's good enough. So we're just going to add a couple more values to this. We're going to put 2 new lines here. And by the way, all of this could be on one line. I'm just breaking it off into different lines of code to make it easier for you to read, but there's no reason it has to be on different lines. This could all just be one line of code. So we will do debug text plus equals XYZ. And then we're going to do mathf.floor to int world.text player.transform.position.x, and then we're going to put a little space divider thingamajigger. I'll do the other side slash because that's confusing things if I do it that way around. And then we're going to do the same thing for X and Z. Or for Y and Z even. And then we'll also do we'll do chunk as well. And you can put any values that you deem necessary. I think in proper Minecraft, it can also tell you what biome you're in, and what light level maybe, or maybe they're mods, I can't remember. But you can put values like that in here as well. Just to make this easier, we're going to just make this value public. There's no reason it shouldn't be public. It just saves us having to do any calculations here. So now we have, I forgot to put a new line in there, but we have our coordinates working. However, you might notice that they're quite a way off. Now, if you remember, the way we're working our actual chunk map and our voxel map and everything like that is we're setting a world size, and then we're creating an array of that size so that 0, 0 isn't the center of the map like it is in Minecraft. It is essentially the bottom left of the map. Because if we go below 0, 0 in our array, then we're going out of the range of the array because it can't go any lower than 0. So we need to do something like that's fine for the coordinates in the game, but to represent it to the player like we are here, we could do with just changing it so that it does actually show the proper coordinates being spawned at 0. I'll just put a new line in here like I forgot to do, and then we're going to create 2 ints up here. Half, fairly straightforward what's going to happen here. Half world size in voxels and int half world size in chunks. And then we're going to set these here. It's just the full world size, obviously divided by 2. And all we need to do then is minus half the world size from these, and then that gets us our coordinates, treating the spawn point, which is, so if we had a world size of 100, spawn point would be 50 by 50. However, by minusing half of that, we would then, our spawn point would be 0, 0, and it would go to minus 25 and plus 25 in either direction, as opposed to starting at 25 and going to 0 in one direction and 50 in the other. So all we need to do is minus half world size in voxels, but we will need to enclose this in brackets because the string building system here needs to treat it as one value. And then the same over here. And we don't need to do anything with the Y value because, again, the Y value is just one. There's only one chunk vertically. And then we need to do the same thing here. And now if we press play, we have a more accurate representation that now goes to minus coordinates. And we have a nice smoother chunk generation system that doesn't completely lag the game out when we're running around like we are now. And that's the end of this tutorial. I'm sorry it wasn't the tutorial that I know everyone's waiting for, the breaking and creating blocks. We'll get to that in the next one. Possibly not next week, because I've got another video that I've been wanting to get out. But it will be the next Minecraft video, and we will get straight into that next time. Thank you again, everyone who's subscribed, all the new subscribers. Like I said before, I'm amazed that that many people are interested. And I hope this video was interesting and helpful, and I will see you next time. Bye bye.